an equation of one or more partial derivatives of an unknown function in two or more dependent variables is called partial differential equation. So in this video, we want to talk about how to eliminate constants in forming partial differential equation. That is when you are given an original equation and you have to form a partial differential equation from that given equation. So that is what we want to do in this video. So partial differential equation. So let's look at the exercises, which are examples. We are asked to find the partial differential equation by eliminating A and B from the relation. We have one. The first one is Z is equal to AX plus BY plus A squared plus B squared. The second one is Z is equal to X minus A all squared plus Y minus B squared. The third one is Z is equal to A into X plus Y plus B. The next is Z is equal to AX plus BY plus AB. And the last one is equal to X minus H all squared plus Y minus K all squared plus Z squared is equal to lambda squared. So these are the given relations from which we are to eliminate A and B in order to form our partial differential equation. So let's take them one by one. We start with the first given problem. Start with the first one. The first one is saying that Z is equal to AX plus BY plus A squared plus B squared. Now, to solve this, let's write the solution here. Good. Now we have to recall, let's P, an arbitrary constant, be equal to the Z, that the partial derivative of Z with respect to partial derivative of X. And let Q be equal to partial derivative of Z with respect to partial derivative of Y. We can also have R to be equals to, the second partial derivative of Z with respect to the partial derivative of, X dx, We also have we can say Ix is equal to the partial derivative of, we are trying to, get, okay, this one is dx squared. Sorry about that. This is the x squared. So x will be partial derivative of z squared all over partial derivative of x with respect to y. Yt is equal to partial derivative of z with respect to partial derivative of y squared. Okay, so now these are the constants we usually use. Now, but in this case, we want to eliminate A. A is here, B is here. A and B are our focus for elimination. A and B are our focus. Let me clean everything. So we start, writing them once again. That's our focus. We want to eliminate A and B. So we can clean this. If we need them, we use them. But you must first of all note those arbitrary constants as an assumption. So again, the question says Z is equal to AX plus BY plus A squared plus B squared. Now, let's first of all differentiate partially with respect to X. And differentiating partially with respect to x, that is, going to find the z, the x. If we do that here, we have a throughout. There's no x variable here, any x variable here again. So that is for the x, the z, the x. Now the z, the y, you differentiate partially as well with respect to y. See, this is the only place where we have our y, and if you differentiate y partially, you have b. So let's call that b. Okay. Now let's now assume. Okay. Let's assume that. What are we assuming? Let's, from our assumption, initial assumption here, the z, the x, which we get to be a here, now equals to p from our assumption. When we differentiated z with respect to x, we got a. The a we got here is one of the constants given to us in the equation. But invariably, this p is equals to dz dx is the same thing as what we get here. That's why we are saying that let's dz dx be equals to p. And dz dy, which we obtain as b, let's be equals to, our dz dy was originally assumed to be q. So having got this now, the next thing is now to substitute into the given equation. Therefore, by substitution, we have, what do we have? Beautiful. Z is equal to, our a now, is b. It's no longer a. That'll be p, then x, plus, then what's our b? Our b is now q, and our y, then plus a squared. A squared is automatically what? P squared. P squared, then plus, what is our b? B is q now. Q squared. So this is the required equation. This is required, which invariably means that you are saying, z is equals to the z, because p, the x multiplied by x. So you can write x to the front. You can write x first. X dz dx plus q. Your q is dz dy. Y dz dy plus p squared. That is the dz dx all squared. Then plus q squared dz dy all squared. So this is what gave us this. So actually you can leave your answer like this. It's correct because you have, but you must have stated the assumption from the beginning. You must have stated the assumption from the beginning that p should be equals to dz dx and q should be equals to dz dy. So that is that about that. Don't let us waste too much time on that simple question. So let's go to another question. Now the second question says that z should be equal to, second question 2, z should be equal to x minus a all squared plus y minus b all squared. Beautiful. Now, like I said, we have to differentiate with respect to x and y partially. Then we do substitution. That's all. We are only doing two things. When you have assumed that your p should be equal to the z dx and your q should be equal to the y, the z dy. So let's solve this. Now, the z, the x, we are differentiating what? Partially. Is equal to, you bring 2 here normally, you can remember your function of functions. Now when you bring 2 here, 2, then you differentiate what is inside the bracket with respect to x. You are going to have what? 1. Yes, because when you differentiate x minus a, you have what? 1. Then you now repeat what you have in the bracket, x minus a. Remove 1 from the power, it's 1. So you don't need to write 1 here again. Then that is for what? This implies what? You have 2 into bracket x minus a when you expand this. Now for the partial derivative of z with respect to y, do the same thing. You don't have y here, so this one does not concern you. The variable y is here. So you have, bring 2 here, you have 2 into, that is the 2 here, what? 2. Then differentiate what you have in the bracket, you have 1 with respect to y. Okay, 1. Then multiply it by everything in the bracket again, y minus b. So subtract 1 from this is 1, so you don't need to write that. So that what? 2 into y minus b. Okay, now with what we are asked here, we are told that we should substitute whatever we get, and don't forget that we said our dz dx should be p and our dz dy. So I could equally say that this is what? This is p and this is what? Q, because from here. Okay, now by substitution, let's now substitute. Let's substitute into the given equation. Okay, so we have what? Z now will be equals to x minus a all squared. Now look at something here, very funny. What is our x minus a here? You know, our x minus a all squared. If you want to write x minus a all squared, that means we're going to what? Find the value of x minus a here. Okay, so that means we need to find, make x minus a, solve a formula here in order to get the equivalent value that we're going to put here. Are we together? So let's now find from equation 1 and 2, let's find the value of x minus a and y minus b as well. So from equation 1, let's call this 1, I call this 2. So x minus a will be what? X minus a will be p all over 2. That is it. So if x minus a is p over 2, and our target is to get what? X minus a all squared. So x minus a all squared what? P squared all over 4. That is the square of this. Okay? Now, for the second one, from equation 2, y minus b will be equals to what? Q all over 2. So, y minus b all squared, because we will need it here, we want what? Q squared all over 4. Okay? So now, the next thing after getting that is now to substitute into the given equation. You now substitute into the given equation. Let's substitute it to the given equation. Because we want to eliminate, we are trying to eliminate a and b completely. Okay? Don't forget p squared. Okay, so now that means by substitution now we have what? Z will be equal to x minus a all squared has given us of p squared all over 4, then plus y minus b all squared has given us of q squared all over 4. So if you like, you can say you factor out for that 1 all over 4 into bracket p squared plus q squared. So z is equals to 1 all over 4 into bracket p squared plus q squared. So that is that about that too. Let's go to the example 3, the question number 3. Let's go to question number 3. Let's go to number 3. I hope you are getting it. So the very first thing you do is differentiate partially with respect to x, differentiate partially with respect to y, then make substitution, that's all. It's very simple. We are taking 2 steps. Now the third one, z is equal to a into bracket y plus b, sorry about that, that's a slip of tongue, x plus y plus b. Okay? Yes. Now, as usual, we what? We differentiate partially with respect to x. The z, the x will be what? Don't forget, this is a constant, you know. If you differentiate a constant, bring it out, just like product rule. Bring this one out, you differentiate this plus everything. So, now when you differentiate what you have in the bracket here, with respect to, don't forget, with respect to x, it will be 1. Because you don't need this. You can't go to this. Your target is to get what? Differentiate x. So this will be 1. So a times 1. You get what I'm saying now? It's just like product rule, where this one is u, this one is v. You keep this one constant, differentiate this, plus you keep this one this constant, differentiate this, differentiate them. You alternate their differentiation. So this is a constant, now differentiate this. You have 1. If you now bring all this here and differentiate this will be 0. So 0 times everything here is going to remain that. Now that is what that will give us a for the z, the x partially. Now the z, the y will give us what? Let's try. Just the same thing. A into what? Into what? Into y. Because this one will be 1. Okay? I hope you are getting very good. Very good. So that was a. Okay? I hope you are getting it. This is a constant. All this will be 0. So that's why we don't need this. It will be 0. So that implies that the z, the y is equal to what? Is equals to a. And don't forget from our assumption initially, we said our dz dy should equal to what? P, and our dz dx should equal to P, and our dz dy should equal to Q partially. So now let's substitute. Let's substitute into the given equation. So we have what? We have z is equal to, our a now is what? Is p. So we have p into x plus y. Okay, p into x plus y plus b. That is one equation. That is when a is equals to p, we have that. So when a is equals to what? Q. Z is equal to q into x plus y plus b. That's equation 2. Are you surprised? Don't be surprised. Because we got the same value for a, for p, and q. So now substitute into the given equation. So this invariably means what? This invariably means 1 is equal to 2. Equation 1 is equal to 2. And so if equation 1 is equal to 2, that means p into x plus y plus b is equal to what? Q into x plus y plus b. So if that happens, it means that automatically it means that this is equals to this. So you can either use any one. Yes. So the equation means that you can either use either this is equals to this or that is equals to that. Invariably you are going to get the same thing. Don't get it twisted again. Differentiate partially with respect to x, you are going to have a, because this will be 1. So this is 0. When you differentiate partially with respect to z, you are going to have a also. So that means p is equals to q. Without wasting your time, we can conclude. Therefore, we conclude that p is equals to q. That is, z is equals to this equation. That is, z is common to them. This is equals to this. Everything is equals to each other. P is equals to q. That solves the problem. Let's go to question number 4. 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 Now question number 4. What does that say? That says number 4 says z is equals to ax plus by plus ab. Now differentiate partially with respect to x. We have dz dx equal to, this is what? This one will be left with 1. No more x. So that is equation 1. And you can call that what? Your p. Dz dy will be equal to, you don't need this because you want to differentiate with respect to y. So you are not concerned about this. So this will be what? If you differentiate with respect to, this will be a. We are differentiating with respect to x will be 1 times a. Sorry about that. So when you differentiate with respect to y here, this one will be b. Okay? Beautiful. That's equation 2. Now, don't forget, this is the same thing as what? Your p, and this is the same thing as your q. So now by substitution into the given equation, you have what? Z will now be equals to, your a is now p, px, plus your b is now q, qy, plus a is what? P, b is what? Q. It's as simple as this. This one is even simpler than the previous one. So it's as simple as that. So you have formed the partial differential equation of the given relation. Now the last one here. The last one. Fifth question. To solve this, what we also have to do is to differentiate partially with respect to x, partially with respect to y, and substitute as usual. But we should note something. Anytime we are differentiating this z is an implicit, it's just like z is a function of x. So you can say z is equal to z of x comma y. So whenever we see z, because remember our z is acting as y in the normal calculus, so we are going to differentiate it partially, and we are differentiating it not only partially but implicitly. So in this case now, to differentiate this with respect to x, we're going to have what? We have 2 into the whole of this is 1, because when you differentiate x here is 1, then x minus h, you subtract 1, that goes, that will go, that's everything here with 1 now. Then this whole of this will be 0 because it doesn't have a x variable. Then plus, now 2z, the z, the x is equals to 0. That forms equation 1, yes. 2z dz dx. Why? Because we are differentiating z implicitly, as if we differentiate y in our normal differentiation. So that forms equation 1, which is, in other words, we can write it as 2 into x minus h plus 2z dz dx equals to 0. But I think we can write it in such a way, in a better form. Let's say 2 into x minus h plus 2zp equals to 0. Beautiful. We are still solving. So, wow. So we can write is it possible? Oh, yes, we can say that. Okay, let's leave it like this first and see what will happen thereafter. Maybe we need to do some manipulations. Now, I made some algebraic operations. So let's now differentiate with respect to what? Y partially. Oh yeah. Differentiating with respect to y, there's no y variable here, so you leave all this. Then we have what? 2 into 1, then y minus k, because this one will be 1 minus 1, that's, then plus 2z, the partial derivative of z with respect to y now is equals to 0. Yes. So that will give us what? 2 into y minus k plus 2z. Remember your dz, the y is what? Is q, equals to 0. That is equation 2. Okay, so with this, don't forget we actually need x minus y h squared, y minus k squared to form our equation. So that means we will actually need them. We need these values. Okay, so from equation 1, you can get, you see that we're going to have what? 2 into x minus h will be equal to minus 2zp. You get that? Taking 2zp to the other side. So this will cancel this out. So you have what? X minus h will now be equal to minus zp. I hope we are getting that. So that means, and we need x minus h squared. Don't forget, we are going to use that. Beautiful. That means we are on the right track. Now the second one, from equation 2 now, from equation 2, but yeah, let's pick from 2. We have what? 2 into y minus k is equal to minus 2zq. Beautiful. So you can see 2, we cancel here. We have y minus k is equal to minus zq. Fine. So we have gotten x minus h is equal to minus 2zp, and we have gotten y minus k is equal to minus zq. So let's now substitute. The next thing is to substitute. The next thing is now to what? To substitute. Oh yeah, by substitution. Now by substitution. X minus h squared is what? That's minus zp all squared. Then plus y minus k squared. That is minus zq all squared. Plus z squared is equal to lambda squared. Don't forget, lambda is an arbitrary constant. So, by the time you expand this, you have what? You have z squared p squared plus z squared q squared plus z squared is equals to lambda squared. So, z squared is common. You have z squared into p squared plus q squared plus 1 is equals to lambda squared. I hope you are getting it. So with this, we have come to the end of the problem. So the problem is as simple as that. You can write it like this, and if you like, you can divide through by p squared plus q squared plus 1, so that you have z squared equals to lambda squared over all this. But you don't need that. With this, you have gotten to the end of it, and that is it. So please don't forget to do well by clicking the notification bell, so that each time I upload a video, you'll be duly notified. I am Dr. OJ. Thank you.